There is a whole lot of stuff going on with that. We need to see the before and after. My controls are gone. All right. You know what? We'll just do it live. You're up for this. All right. These images of before and after, I've seen this. That's not bad. We can just go right here with the first one. Well, of course, it's a bad website. Whatever. It's going to make me log in. It thinks. Yeah. This is the before and after. You can see how much material was cut out of that mountain. Yeah, we're not doing that. What in the world? No, that's still, again, it's a Pinterest site where you can, this is one where you can slide it back and forth. All right, we're not going to spend that much more time looking at it, but there are Washington State.edu. There we go. Or Washington. So school's closed for the spring. Here's the before and after that's most iconic. Height of the mountain is gone. The side of the mountain, there's this giant missing hole here. All of that was ejected out sideways in this huge pyroclastic event. Before we talk about the crazy kind of volcano stuff again, let's go back. Let's calm this down and have a nice, quiet Pahoehoe flow. What the hell is Miller talking about? Pahoehoe what? Here we go. And I am
Pahoehoe.
saying that right. Pahoehoe is a type of lava. Okay? It just is Pahoehoe and Aa. Those are the two lava types that we're going to worry about. We're going to start there with really simple things, okay? What makes an eruption explosive versus quiet? Just some lava rolling down the side versus this huge whoosh explosion. Composition of the rock, chemical composition, the magma, or sorry, not of the rock, but of the magma, the temperature, the amount of dissolved gases in the magma. That's what controls what kind it is, okay? A couple of vocabulary things. A vent, first one, vent, that's just where there's an opening to the magma chamber or to the magma. It's an opening to the surface. Yeah. Here we go. Pahoehoe. Rope lava. This is someone sampling rope lava from Cornell, okay? This is a trained person. Don't just go out and do this or your shoes will melt. Stepping here versus stepping here, not okay. Your shoes will melt. But this smooth, ropey, flowing, you could see that it's stretching. The top of this starts to cool in the air and it forms this little skin or this crust on top. But then the magma inside is pushing and rolling down the mountain. So right here on the front, it wrinkles and then breaks back open and then forms a new crust and keeps coming down the mountain. This stuff is actually the faster moving of the two, Pahoehoe versus Aa. The Pahoehoe moves 100 meters an hour. So it'll cover a football field or two per hour. All right, let's look. More different types of lava flows. So there's the smooth Pahoehoe we're talking about. All right. It's basaltic lava. Okay. They always talk about it in terms of ropey. All right. We're going to compare it to the Aa. Jagged, crunchy, spiky lava. Think when you think pumice or lava rock, that looks more like the Aa. All right, that's Aa. This is off of Mauna Loa in Hawaii. Obviously bigger, taller, slower. It's going to come down the block in a couple days, not a couple hours. But it's moving. All right, It's just a whole bunch of loose little things piled up. The inside is flowing, and they're just kind of riding down on it. And then what's on top falls off, lands here, and then the molten lava comes right over the top of it. There's all sorts of stuff going on. All right. What do we know? All right. Pahoehoe can change to depends on if you get it going fast enough or if the temperature changes, but not very common. We're not worried about that. That's when you become a geologist, right? If you start studying that. So it pools, it starts to change, and it goes down the mountain uneven and breaking up in stages. The flows are crunchier, they're more jagged, lots of different stuff. And when we say lava flows, what are the things we're talking about? We are talking about broken rock. We're talking about lava bombs, fine ash, gas, the lava itself. So the two types of lava are the Pahoehoe and the The other things that can flow with it those are the broken rocks, the gas, the ash. Those are the other things that erupt out of this. All right. So the gases, the typical gases dissolved in these rocks don't make up a huge percentage, but just like a soda, as soon as you open the can and release the pressure that's inside there, the gas that was dissolved in the liquid of the soda, the gas that was dissolved in the rock, now escapes and fizzes out. So about 70% of what's in the rock is water vapor, 15% carbon dioxide, 5% nitrogen, 5% sulfur. Those are the gases that are dissolved in there. But the thing is, those dissolved gases, when you release them, gas is going to expand really fast, and that's going to cause this lifting, and that's what can give you an extra oomph at the top and raise those ash clouds so high. All right. Lava flows. This is Pahoehoe flowing over top of and it's coming down the mountain the same way. That's just showing the fields. Different cool pictures of the way this stuff wrinkles and forms and moves. All right. Size. Okay. Dust, powder, ash. Lapilli. All right. Anything between a pea size and walnut size. So little bitty rocks. Okay. Smaller than rocks. Pea gravel. They're cinders. When the ash erupts, when the volcano erupts, it goes up, it solidifies, it rains down, and you get a whole bunch of because you've got all these loose little chunks and rocks laying on top of each other. The other thing, you can get blocks and bombs. Okay. A block goes up, turns solid, falls back down, clunk, clunk, clunk. A lava bomb goes up, stays molten hot, comes back down, and sears whatever it lands back on. But they're bigger than the walnut. The 64 millimeters is some defining size that geologists have. So it's above that and below that to get blocks. And above that gets you blocks and bombs. Below that gets you cinders. So these are the materials that are produced in the eruption. These are the fragments. They also can build up these cones slowly over time. Okay? All right. The other thing that you can get, this is kind of interesting, is showing like super specific things. We're only going to worry about the broad scope. Super specific things here. As these fall, the wind's going to stretch them out, and then they're going to cool in these weird teardrop shapes. And that's talking about all the different things. You know, if it partially cooled on the way down, fully cooled on the way down, whatever. All right. Ready? Whoo! Types of volcanoes. Okay, let's not look at that. Big picture, we are going to worry about 3 types of volcanoes. Shield volcanoes, cinder cones, and stratovolcanoes. Composite cones. Composite cones are also called stratovolcanoes. We're going to worry about those 3 types. There are other things where there's a hole in the earth and magma comes up and becomes lava and sails off. We're going to worry about calderas, necks, and pipes next time. All right, we've got enough material today. This is kind of going to draw out. All right, all three types: shield volcano, cinder cone, and composite cone. All three, okay? So there's a fissure or a crack deep in the crust. Magma is forced towards the surface. Magma comes up through the fissure, which ends in a vent, because the vent's the actual opening to the surface of the earth, okay? You build the mountain with this stuff, all right? Every now and then, the summit of these things will collapse and you get a crater. It's a steep-walled part of the volcano at the summit. It's a crater. We all kind of know that. All right. Repeated eruptions build these materials. All right. First, shield volcanoes. These are the islands. This is the Hawaiian island. They are massive in size. They're not really steep. They're big flat pancakes. Okay? You're going to accumulate a whole lot of basaltic. See, I didn't talk about what these were made of earlier. I just said there's different types. But these are the basaltic types. Like, think back to last semester. They've got more basalt in them. They're lava. It's very fluid, okay? It flows down the mountain. They're broad. Most of these start actually deep, deep in the ocean, and they have to build up for hundreds of years, thousands of years to break the surface, and then they build up. And we talked about the Hawaiian Islands. There's a hot spot under the ocean, and the whole plate's moving across. And so the plate, different weak spots in the plate become the center of the volcano over time. Hawaii is a great example of this. Iceland is a good example of a shield volcano. Big, fat, broad shield. Okay. Cinder cones. Cinder cones. In fact, the cinder cone, that word is not even on here. Okay? It's probably this Soma volcano over here that we're thinking of. Okay? Cinder cones are the traditional volcano. It's what you think of when you think volcano. It's baking soda and vinegar science project. It's a steep mountain, got the big crater in the top, the whole thing. Okay? So the ejected lava, pushes up a whole bunch of cinders. Remember the little pea-sized fragments of loose rock, and then they falls and it hardens. Hardens in the air and builds up this cone. All right, again, it's a lot of gas in there because it erupts upward. All right, the shield volcanoes are more flow. This is a cinder cone, goes upward. Simple shape, steep sides. The material forms as it lands. Here's the thing. There are thousands of these cinder cones all over the globe because they're kind of common comparatively. They'll erupt for a few weeks and go away. They'll erupt for a year and then go away, and they're done. They're dormant the rest of their life because the cone, the chamber leading down to the crust, solidifies. It's a one and done event. It'll erupt and spew all this material out over and over and over, and then it stops. And it's done. But when it erupts, it wasn't slow and steady. It was there was a lot of gas, there's a lot of lift up, and all the cooling stuff's going on. All right. Composite cone. Composite cone is the stratovolcano. That's what's next. Okay. These are all around the Pacific Rim, the Ring of Fire. Okay. They can go from the Alaska and Aleutian Islands down to Japan, to the Philippines, to New Zealand. Okay. These are large cones, the large cones that are in the Andes Mountains, the large cones that are in the Cascades, Mount St. Helens, Mount Rainier, Mount Shasta. These are good examples of stratovolcanoes or composite cones. Okay. They're nearly symmetric. They're very pretty. They have both types. They have both lava flows and the pyroclastic big up eruptions with the coming down on it. All right. Gas rich, but instead of having a lot of basalt, it's got a lot of andesite in it. Okay. The other thing is the lava is much more viscous. So viscosity is the thickness of the liquid. Syrup is more viscous than water. So the higher the viscosity, the more sluggish and syrupy it is coming down the mountain. This lava flow, it does flow, but it's more viscous, which means it's going to go a little ways and then cool and then repeat over and over and over. All right. These can get you the pyroclastic flows. They can also get you the lahars. Remember those mudslides? You saw the mud going under the bridge on the Mount St. Helens video. That's what's going on here. All right, so let's get rid of that. We don't need to Google search because here we go. So Shield Volcano starts at the ocean base, moves up, really smooth, slow slope. Hawaii. Stratovolcanoes, the composite type. This was the third one we mentioned, okay? You can have small branches off of this, all right? But you can have both lava flow over time, these dark materials over and over and over and over. But you can also have the pyroclastic big eruptions going on. And the Cinder Cone has the big sunken crater at the top. This is like a one-time, short-lived, steep guy, over and done. Those are for later. Okay. Here we go. To scale. Here's the ocean. This is Mauna Loa in Hawaii. This is the mountain. It is ridiculous. If you get to count all of this from the floor of the ocean, again, I think we mentioned it, it's taller than Mount Everest, but we don't. So you go from here up. It is very broad, very flow. Lots of pahoehoe, right? Lots of flowing lava, not huge, crazy eruptions spewing the everywhere. By comparison, the same scale, height and width. So height, these aren't that different, but you got to start from here. All right, this is Mount Rainier in Washington. It's got a crater. It is the Composite Cone, the Stratovolcano. And then here you've got the Cinder Cone, Sunrise, Arizona. What are we looking at? There's a good picture of Mauna Loa in Hawaii. There's Mauna Loa, and then Kilauea is off to the side. I think the orientation north-south is right. I think that's Kilauea. This is Mauna Loa. Here it looks much steeper than it is, but remember this thing keeps going out broad here into the ocean. All right? So that is a shield volcano. This is Mount Rainier. This is the Composite Cone, the Stratovolcano. There's a good picture of it. This thing is huge and massive and just sticks up out of, well, that's still a good picture of it. All right. And Sunrise Crater in Arizona. Huge crater in the middle. This thing collapsed back in and cooled off and sealed that off, and it's a one and done. There might be chains of these. There's rows of these, but this is not going to erupt again. So you got all that kind of crazy stuff going on. All right. We are going to, there's two other mini types like calderas, necks, and pipes that aren't volcanoes by name. We're going to look at those next week along with some other properties. That next week. Monday. We're going to wrap up. So plate tectonics, volcanoes, that's our good unit. Then we'll get into earthquakes and some other stuff. Guys, have a great day.